All right, good afternoon again. Okay. Today, I would like to share with you my experience about teaching undergrad courses, especially by using drawing tablets and also video capturing. You will see exactly how I do it. Okay. First of all, let's go over the challenges from my personal point of view about teaching undergrad courses. I'll give you two challenges I face myself personally. Number one, we all want to transfer complex computational thinking to students' mind. However, they got very limited exposure prior to the course, so it's difficult for them to take it right away. For example, if you want to teach about nested loops on two-dimensional array, you can feel free to find example in the paper. But for today, I want to give you another example about how you can teach object-oriented programming, especially aliasing. Okay, that's something I will do in just a moment. The second challenge would be when you got scheduled in-class lectures weekly. Students still, even for students who attend the lecture, they still find they gain very limited comprehension. But why? One reason could be the large class size really restrict the way you interact and pause the lecture with the students. For my own example, this is the lecture hall for me to teach the first year undergrad course. So the lecture hall can accommodate up to 500 students, very huge. You don't really want students to ask questions. It's really that way, okay? Okay, so that's the first reason, and the second reason could be very important. Every time when you give a lecture, because you understand the subject very well, every time when you're trying to make a verbal remarks or written notes that really represent your personal insight into subject matters, you really want the student to get it. However, it's really hard for students to both copy down the remarks and also understand the remarks at the same time. It's simply not possible. You really want to have a way for the student to reiterate all the remarks after the class. Okay. So now, how would you help these typical students who got very frustrated? The student might just say to you, I did attend all the classes. However, I failed to follow what you are teaching completely. It's not really the student's fault. It simply just takes time and takes repetition for them to understand. So how can we solve this problem here? So this is my motivating question for this experience report. How can we make the in-depth illustrations in the class, which represent our insight into the taught subjects, how can we make it accessible to the students so that they can review them on their own pace outside the class? So outside the class is really important because you got very limited lecture hours. You want the student to spend their own time in their own pace. Okay, so let me summarize the contribution for this paper very quickly, and then we'll do some demo. It's really about a technique for in-class illustrations of complex ideas on the drawing tablets. Okay, you'll see exactly what I mean in just a moment. What the instructor should do before the class, they have to prepare the so-called starter artifacts, like code fragment. You'll see example as well, so that the instructor can actually do frequent and heavyweight annotations on the drawing tablets. So frequent and heavyweight are really important. Okay. The number two will be allow the student to review the entire process for you to do the illustration. Okay, not really just the final outcome, but the process of building the solution. So now let us illustrate this technique using a review lecture on OOP, object-oriented programming. And do me a favor. At the end of the lecture, pretend you're a student. Ask me one question. I will also demonstrate to you how I answer questions to students. Okay, just one person, one question will be enough. Okay, so now let's start a sample lecture. What we want to do is we want to consider the model of a person. Let's use Java, object-oriented language over here. So now here we have a class called person. A person is characterized by two attributes, weights and heights. Let's assume weights is in kilograms and height is in meters. There's a reason for that, okay? And we have the constructor for creating new person objects, and we got two parameters, weight and height, because their names clash with the attribute name. So we can use this keyword to actually disambiguate, okay? And then we got the accessor method to calculate the so-called body mass index, that's BMI, okay? By the following formula. You simply just do weights divided by the square of heights. Okay, very standard, a very easy computation. We also got a mutator here, which will change the weights. Let's assume, for simplicity, the amount to gain the weights from will be non-negative, okay? And we can change it. That's the entirety of the person model. Let's consider another tester to test the behavior of the person class we just saw. And we have a main method here, so we can print out something to the console, which I will also demonstrate to you in some IDE. Let's say we create two person objects, Jim and Jonathan. Okay. And for example, Jim has 72 kilograms heavy and also 1.72 high, and similarly for Jonathan, just different numbers. And then we try to print out Jim's BMI to the console. You can see I'm trying to say Jim.get BMI. If you recall from the previous lecture, Jim over here is called the context objects. Let me print out also the BMI for Jonathan. In this case, I'm calling the same method, get BMI, but the context object is different. It becomes Jonathan, right? So Jim and Jonathan. And now the most critical line is line number 9. I'm doing an assignment from Jonathan to Jim. I wouldn't tell you what exactly you will do because you're supposed to know from the previous lecture. Okay, let me just leave that to you just for now. And then I would say Jim should really gain the weights by 3. That means supposedly Jim's BMI should really get increased. And also only Jim's BMI should get increased because it's only Jim who gained weights, right? Intuitively, that's how you should think. And we try to print out the BMI for Jim. We try to print out the BMI for Jonathan as well. So there'll be 4 numbers in total to be printed, right? So now, let's first of all, before I try to show you the eclipse, you got about 5 seconds to anticipate what the output should be in your mind before we see the answers. Let's verify the answer in eclipse over here. Sorry for the font size, but basically it's exactly the same tester we just saw. I simply just going to launch the program, and we got exactly the 4 numbers that we're expecting. Now, just for you to be easier for you to see, let me go back to the slide. I already copied the number over to the slides. Let's go over that. These 2 numbers before Jim gained 3 kilograms, I can tell you that they're correct. Okay, they correctly applied the formula, and we simply got 24.34 and 19.84. Okay, these 2 numbers are correct. However, after Jim has gained 3 kilograms, we got these 2 numbers. Somehow, I claim it contradicts with our intuition. Let me ask you 2 questions to help you understand why there might be a contradiction. After Jim has gained weight, question number 1. Why was Jim's BMI decreased from 24 down to 20? Did he not gain weight? Number 2, why was Jonathan's BMI increased from 19 to 20? Wasn't Jim the only person who gained weight? So maybe something wrong with Eclipse, or something wrong with our program, or maybe something wrong with our conceptual model about intuition. I guess the latter would be the case. So now let's illustrate how this happened. Okay, let me now switch to iPad over here. Okay, so this is what I so-called the starter artifacts over here. I already built up something for you, so I don't need to write something down on a conventional blackboard or whiteboard. Okay, let me do very quickly. So over here, we got a person class, we got 2 attributes, we have our constructor, we have our accessor and mutator over here, right? Something we already went over in details. I want to talk about the person tester quickly in detail and show you how you can visualize and understand what's going on, okay? The first line I would like to go over is this. Let's say we try to create the first object, Jim, and Jim is going to store the address of this particular objects, right? That's about objects. And then it's going to be 72 and 1.72, 72 and 1.72 over here. And then what about the second object? The second object, we have Jonathan here. So Jonathan is going to point to this particular object over here, and the number is going to be 65 and 1.81. Okay, so far so good. That's how we created the 2 objects. And now I want to consider these 2 lines, Jim.getBMI versus Jonathan.getBMI. The context object is different. For the first one, because the context object is Jim, that means we are calling this getBMI method over here. Every occurrence of this, the current object is going to be replaced by Jim. Every occurrence of that. That's the first call. So that means we're going to apply the 2 numbers over here, pointed by Jim. What it will do is it's going to calculate 72 divided by 1.72, like that, right? And then for the second call over here, the context object now becomes Jonathan. We're calling the same block of code the second time. And now every occurrence of this is now replaced by Jonathan instead. So that means the same calculation, the same formula, but now it's going to be 65 divided by the square of 1.81. Okay? And these are exactly the 2 numbers you just saw over here, right before Jim has gained 3 kilograms. So now the key really is over here. The most critical line for you to understand is really this line here. Jim is assigned to Jonathan. So what does that really do? Remember, every reference variable stores address only, not the contents of the objects. So that means what we have to do over here is to copy whatever address in Jonathan into Jim. Diagrammatically, how do we change? So now Jim, rather than pointing to this object over here, is now going to point to this object. So that's so-called aliasing, exactly over here. So the two reference variables point to the same objects. So now if you review Jim.getBMI and also Jonathan.getBMI, both context objects over here, Jim and Jonathan, they simply just point to the same object over here. What does that mean? When you try to call getBMI and getBMI over here, you're simply just going to use the same number. I forgot to do one more thing. Okay. After we have done this reassignments, you also have to say Jim.gainWeights, right? But now, when you say Jim.gainWeights, Jim is pointing to this particular object. So gain weights, you're going to increment from 65 to 68. But it's as if you try to increment Jonathan's weight at the same time because they point to the same objects. Okay, so now if you try to calculate the BMI for these two, it's simply just going to be 68 divided by 1.81 squared. This is why, if you go back there, we got the same number over here, okay, 20.76. So now this example here really shows that aliasing, okay? Do you have any questions for me? We got 1 minute or so. Any questions for me? So I can, doesn't matter how basic it is. Yes?
So are these students having the same head on their machine?
Yeah, so they try to, maybe this is like a question for the lecture itself. Pretend you're students.
Oh, okay, never mind.
Actually, I have two questions. One is that why I have to assign Jonathan to Jim?
Why do I have to assign to Jonathan to Jim? Over here, you can see, oh, you know, it's just part of the question. Because now I just wanted two variables to point to the same objects.
Okay.
It's just part of the setup.
So the second question is that what if I want to just update the data for Jim?
Oh, okay. The question was, you can see over here, if I just got Jim is assigned to Jonathan over here, so this is the assignment that creates the aliasing. Because after this, Jim and Jonathan, they will simply just point to the same objects, right? So back to your question. You want to say, I only want to change the data for Jim, but not for Jonathan. That means don't do this, right? Because every time in Java, since we talk about reference variable, every time you copy reference variable over, you're going to have trouble. Well, you're going to have the consequence of aliasing. Yes, quickly, please.
Question. Can I go back again?
Yes, absolutely. Wait, you mean the code?
No, I said, can I reverse the assignment? Undo this afterwards.
You
Can
mean?
I get Jim to point to Jim again?
Okay, sure. That's a good question. I like that. Okay. Let me just go back here. Okay, let me just answer Rick very quickly. Okay. Okay, so what you're asking is, we keep this assignment over here, and then what you want to do, let's say after this, you say, well, because intuitively, if Jim was actually pointing to Jonathan, why don't I let Jim point back to itself? If I say Jim is assigned to Jim over here, and then after this, I still say get BMI, Jim.getBMI, sorry for the writing, and also Jonathan.getBMI. In this case, are we going to get different BMI? Intuitively, I should really restore Jim back to its old objects. Is it going to? Well, guys, you should really review the OOP, right? Okay, just very quick answer to Rick. So the answer is no, it's not going to. Because if you simply say Jim is assigned to Jim over here, it's simply just going to copy the address, the same address to itself. So Jim remains to point to the same object here. Doesn't really help. If you really want to do it, you can do something like a swap. What you can do is you can say, for example, person over here, old Jim is assigned to Jim, right? That's how you do a swap. And then after that, you can say Jim is back to old Jim, right? That means we are creating old Jim over here. That's really the fun for OOP. Okay, good. Now I can switch back to my presenter mode. Okay. So what I just demonstrated was really a teaching pattern, choreographing several ingredients over here. Number one, we use a slideshow to specify the problem. Okay, so show the problem like a BMI for person, calculating a BMI for person. Also, we use a programming IDE, depending on what the programming language you're using, for example, Java, Eclipse, to illustrate the solution. How does it work, first of all? And then we use a drawing tablets to really show the student how to gradually build up towards the solution. Specifically, I want you to contrast the two iPad page. This is how we started with. This is the annotated version. If you only give this page to a student as a PDF, may not be so useful. But if you can show them the recording of how to go from here until here, it's much more useful. Okay? And then we got drawing tablets to also answer, for example, Rick's question and also other people's question as well. Okay? So it's completely dynamic. That means you're gonna be good yourself on the subject as well, right? So you dare to do such illustration. So now more examples over here. If you want to see how to teach two-dimensional array, you can see the paper. For the complete example, you can go to my lectures page over here. Hopefully the internet is going to work. So over here, this is all the courses I've taught so far in my institution. So basically ranging from first, second, and also to the third year. You can see many topics over there. You can explore the page yourself. Okay, and then, so let me just do a very quick summary again about the contribution for this paper quickly. Okay, let me just go back here, and then, okay, so now, so me as an instructor, so I can present many things on my desktop. Slideshow, code demos on the IDE, and also drawing tablets over here, right? To actually illustrate. And then for you as students, you can ask me questions, I can also answer you. And everything will be recorded, everything. And then on the second stage, I'm going to process the video and upload it to some online platform. In my case, YouTube. So everything is accessible to the students. I got recording, I got notes, I got source code for the students. And for the students outside the class, they can simply reiterate for as many times as they like at their own pace. Okay? That's really the value for this approach over here. Okay, so now, what the student would get, just some snapshots. So for example, if they go to the YouTube channel for each course, I create a playlist on the YouTube. They will see different video for each lecture. And also when they actually go to the lectures page, they will also, I'll show you this one quickly. If you go to a particular course, for example, over here, you will see for each row, it will show you, for example, this is the topics we're covering, and also the link to the YouTube video, and also the iPad notes. So this is the annotated version over here, right? Without the recording to show you the process of building it, it's really hard to follow. So recording is very useful. Okay, okay. You can see that's kind of just the build up for the annotation. Okay. Yeah, exactly. So yeah, that's pretty much how you would do conventionally. But now everything's recorded and reusable. Okay. Now teaching context. So this approach has been adopted in mainly just for undergraduate teaching. So I've done 7 iterations of 4 courses. If I aggregate the number of students, about more than 1,000, and then it ranged from first, second, and third year. I've been using that to teach procedural programming, object-oriented programming, and also software design, many topics over there. However, for your particular course, for you to teach, the approach should be sufficiently general for you to adopt, to teach any complex idea, as long as you follow the procedure. Okay. Now, finally, I want to offer some reflection about the approach quickly. What does the instructor have to do, like yourself, if you want to adopt? The main thing is about creating the starter pages yourself. So you have to decide exactly what kind of illustration you want to do for the students. And if you compare the drawing tablets versus the Blackboard or whiteboard conventionally, it's really time effective because you don't have to copy all the starter page by hands onto the whiteboard on the fly during the class. Everything will be done prior to the class. And also the starter page on the drawing tablet is digital, so it can be elaborated and reused. And also if you compare drawing tablets and slide animations, it's really valuable because for slide animation, it's completely static. You plan all your steps before the class. However, for drawing tablets, all you need is an empty page or starter page, and then you can decide the pace according to the student's comprehension level. Okay, that's very dynamic. Finally, it really takes repetitions for students to really achieve full comprehension. So recording the whole process, everything that's happening in the class for the student review is really valuable for them. Okay, finally, read my paper if you want to find more details. How to adopt the approach about evaluation. I do have some statistics over there in the paper, and also comparison with related works. And just for your information, a similar approach is adopted to create tutorial videos. They are kind of like offline things for students to study in order for them to complete laboratory assignments, weekly laboratory assignments. Okay, you can. It's going to be a conference held in Toronto in August. If you plan to attend it, I'll see you there. Questions, please.
All right, let's first thank our speaker.
All right. Yes.
So do your students have pen, or are you the only one with pen?
I'm the only one with the pen. Think about whatever I'm doing here is projected to some centralized screen. Yeah.
Are they actually capture that down on their systems, or are they?
No, yeah.
All logged onto your web page?
So,
I'm referring, I did a lot of work, this is my area before I retired. We did a lot of work with the University of Washington, Richard Anderson, Virginia Tech. They built classroom platforms in this kind of ability that are active. Because they had students who all had them. So I was wondering if.
yeah, so in this case, the only way for students to interact is by asking questions. And usually for a large class, I'll repeat the questions, and then I will do the illustrate on the tablets, and then everything's recorded. Yeah. Yes.
So I wonder, each time you teach a certain question, do you have to re-record?
Well, actually, since I said 7 iterations, right? So, in theory, I don't have to, because I repeated some courses for maybe 3 times. But it's because I enjoy teaching, so every time I just record again. Yeah. Yeah, you're absolutely right. So sometimes, maybe for a particular semester, a student more engaging, student maybe like Rick, they ask very good questions, right? So in that case, I'll actually feel much more, comfortable with recording. But sometimes students are very silent. In that case, it mainly just me about talking, not too much illustrations.
Actually, I'm curious about the system, like the administration, like how large is the capacity you are using to store the
Oh,
videos
the videos. I would say, for the raw, I'll give you a rough idea. Let's say for a, let's say 90 minutes lecture, if you want to keep all the raw files, it's about 5 gigabytes. But after processing the file into MP4, it's only about maybe less than 100 megabytes. And then I simply upload it to the YouTube. So you don't have to store that somewhere.
I'm sorry, I should have another question. Is that,
Please.
like, can you trace that how many students will, like, like
Watching.
watch this? Yeah.
I know this question is coming. It's pretty good. Can I just take another question quickly so I can also set it up quickly? Yeah, I'm just need you a link to YouTube quickly. All I got to do is to go to,
It's always a risky moment.
yeah. Yeah, YouTube Studio actually shows you, how many views you have. Yeah. So it takes some time. Yeah.
Okay, real quick question while you're
Yeah.
waiting. Do you find that some students do not come to class because all these great lectures?
I think it's a very good point. I think one of the counter argument, because when I mentioned my approach to my colleagues, they are pretty much against it for 2 reasons. Number one, they're lazy, because you can see all the setup I'm trying to do over here. But number 2, they said that would discourage the student to come to class. This is my philosophy. I should do such quality material for the student who care. For student who actually simply wouldn't come to class anyway, that's okay. I just do that for you. It's a byproducts, right? But I think it's mainly for the student who are engaged. But it would be very good for student actually come to the class, maybe get us about 60% comprehension, and then review the lecture after class. Yes, Rick, go ahead.
So I guess whenever the whole kind of video capture of lectures came around,
Yeah.
There was a lot of pushback against recording in long form.
Yeah.
Do you feel that this methodology swings that pendulum back towards, yes, it's quite good to do long form if it's engaging, or should you break this up into, like, edit it afterwards into, if there was a section on
Yeah.
aliasing?
So your question really is, let's say for a 90-minute lecture, maybe after that I could say, for this particular lecture, this particular part is about maybe aliasing. This part is about answering questions to different videos. I can consider that. It might help students so they can choose which video. You know, a workaround, I can simply put some timestamp, like a link, to say maybe from the beginning until maybe 30 minutes, that's about this particular topic, right?
Ask your students to put it in the comments, just like a normal mix of music.
Yeah.
They would probably do that for you. So they
Yeah.
identify the topics.
Absolutely.
Nice way of crowdsourcing an index.
Yeah. Anyway, just very quick response to your question. Maybe just 1 more minute, quickly.
I think this is going to have to be our last question.
Yeah. So, for example, I'll give you one example here. So this is one of the. You know what? This class may not be very good because as a first-year class, students are not that engaged. So you can think about the number of students in the class is about 450. But here we only got about 397 students watching it. Well, it is a rough estimate. But anyway, I'm trying to say, depending on the semester, sometimes I got extremely high number of views. So some students even came to my office hours saying they watched the video maybe more than 3 times, something like that, right? And some students may not watch them at all. So it's hard to say. Yeah.
All right. Well, we're out of time now, but let's thank our speakers.
Thank you.